We're now going to solve equations that have radicals in them. So for example, I might say solve for x, square root of x equals 5. I'm going to put a small diagram that shows you this. This says I had x, so x is a variable, so I think of it as an open box. You can put any number. I took the square root of that. I took the square root and I came out with the number 5. So that means we're going to do the opposite of square root. What's the opposite of square root is we're going to square both sides. So we're going to square both sides. So in this problem we get square root of x squared. We're going to square both sides. But square root of x squared is just square root of x times square root of x, which is just, we've got two x's in there. So thinking about getting rid of out of jail, we've got a pair, so that just is x. So we can think that the squaring and the square root undo each other. And we get that x is 5 to the second power, 5 squared, which is 5 times 5, which is 25. So in general, if I say square root of box, if I square it, the squaring and the square root undo each other. They undo each other, and that just gives me what's under the radical, which in this case was the box. So we're going to use that idea to solve equations with radicals. We're first going to do square roots, and then we'll try a few with higher indices. So now in this problem we're saying solve for x if square root of quantity 5x minus 4 equals 9. So we are going to get rid of the square root by squaring both sides. When I square the square root, I get rid of that and I release what's under the square root. I get 5x minus 4 is 9 squared. 9 times 9 is 81. I now have an easy first degree equation that I can solve. From here, I just need to add 4 to both sides, and I get 5x is 85. Now my last step is I divide by 5, and I get that x is 85 divided by 5 is 17. Now one of the things about this is we usually have to check whether this is correct. So we'd like to do a check. And we can see here, if I substitute, if I let x be 17, I get square root of 5 times 17 minus 4. And the question is that 9? Well, 85 minus 4, I get radical 81 is 9. 9 is 9. So yes, it is a solution. The reason we're going to have to check is because when we square an equation, we sometimes get what's called an extraneous solution. So for example, if I took the equation x equals 2, that only has one solution, and that solution is 2. If I square both sides, I get a new equation. X squared is 2 squared is 4, but there turn out to be two solutions for this. X could either be positive 2 or negative 2. So squaring both sides of an equation sometimes gives an extra solution than what you started with. So we have to be careful. We have to check for what I call extraneous solutions. As we can see in this particular example, I started with an equation where 2 was the answer, but when I squared it, I got a new equation that had an extra answer of negative 2. So that's something we're going to have to be aware of when we do these square root equations. I now have another example. We want to solve for x. Square root of 5x plus 1 is quantity x plus 1. Like all of these, I'm going to get rid of the square root by squaring both sides. So taking the square root squared, that's going to release what's under the radical. And we have 5x plus 1 is this quantity, this binomial squared. And I like to write it x plus 1 times x plus 1, because then you can see that that's going to require the FOIL. So now I'm going to FOIL the binomials. I have 5x plus 1 is, first is x squared, inner x, outer x, so I have 2x, plus the last is 1. The minute I see x squared, I know I need a 0 on one side. So I'm going to subtract 5x, and I'm going to subtract 1. Now I have 0 is x squared, 2x minus 5x, negative 3x, and it's like that. Now we're ready to factor, and its greatest common factor, x comes out, and dividing x into x squared x into negative 3x. And this is going to give us our two solutions. X is 0, x is 3. This one, now we're going to check. So I'll go to the next page to check the two solutions. We're going to let x be 0, and we're going to check whether radical 5x plus 1 is x plus 1. Letting x be 0, we get square root of 1. Is it 0 plus 1 is 1? Yes. So that works fine. Now we check x being 3. We get square root of 5 times 3, 15 plus 1. And the question is that the same as 3 plus 1? Radical 16, is it 4? And the answer is yes, 4 equals 4. So we know that from our original radical equation had two solutions. So at this point, before we can square both sides, we really want the radical by itself. So we will subtract 7, and that gives us an equation that's easier to deal with. Radical 2x plus 1 is x minus 7. Now that I have the radical by itself, it's easy now. I'm going to square both sides. Square root and square releases what's under the radical, and we get 2x plus 1 is x minus 7 times itself. That's going to alert us that we have to FOIL that binomial. We get 2x plus 1. FOILing, we get x squared, negative 7x and negative 7x, negative 14x, negative 7 times negative 7 plus 49. The minute we have an x squared, we know we need a 0 on one side. So we're going to subtract 2x and subtract 1. That's going to give us 0 is x squared, negative 16x, 49 minus 8 is plus 48. Now we're going to factor, and after some work, we see this will be x minus 12 and x minus 4. We now can see that x minus 12 is 0, so x would be 12, and x minus 4 is 0, so x would be 4. So these are two possible results. In order to see if both of these work, because we have to worry about extraneous solutions, we have to go back to the original equation. And the original equation was radical 2x plus 1 plus 7 equaled x. So we are going to have to check 12 and 4, substituting in for x. I let x be 12, and I get radical 2 times 12, 24 and 1 plus 7. Is that 12? That's the question. And we get radical 25, which is 5 plus 7. 5 plus 7 is 12, so that certainly will work. Now we try letting x be 4. Our other value was 4. We get radical 2 times 4, 8 and 1, plus 7, and the question is that 4? Working this out, we get radical 9 plus 7. Is that 4? Well, radical 9 is 3, and 3 plus 7 is not 4. So what that means is that x equals 4 was an extraneous solution, so it gets crossed out. So for every radical equation, when you get two answers like this, you do have to check to make sure that they both work. So the only solution to our equation was x being 12. We'll go to the next page to do what's maybe one of the harder ones. Now we're going to do this radical equation where you have one radical minus another is 1. Squaring both sides the way it is will create some difficulty because we'll have to FOIL these two radicals. So as a first step, we're going to try and separate and have a radical on each side. For this one, we're going to add radical x minus 2 to both sides. In doing that, it gives us a different equation, but it's equivalent. We now get that radical 2x minus 3 equals 1 plus radical x minus 2. So first step, we're going to square both sides. Square root and square releases what's under the radical, and we get 2x minus 3 but this is a binomial squared, so we're going to have to write it twice. In doing this, we will see that we are going to have to use the FOIL in order to simplify that quantity squared. We have 2x minus 3. We're going to have to FOIL. We get a 1. Then we get one radical plus another radical. We've got 2 radical x minus 2 plus now the last, the radical times the radical is x minus 2. I write this and I'm going to combine like terms on this right side. We have 2x minus 3, and I'm going to put the x term first. I have x, then I have a 1 and a negative 2, so it's minus 1, and then I've got 2 of these radicals.